Okay, we're proving that opposite sides in parallelograms are equal. So we can't assume they are just because it is true. So we have to prove that they're equal. So we're going to just draw a parallelogram. And we're going to say, let A, B, C, D be a parallelogram. Huh? What? Smaller version of? No, parallel is the two lines. Parallelogram is the object, because you can have two lines that are parallel and not be a parallelogram. So yeah, to actually say it's a parallelogram, yeah, you need to say it. So what we've done is we've drawn a parallelogram. We're calling it a parallelogram, and we've drawn a diagonal from A to C. Everyone happy with that? Okay. Now, we haven't put any marks on the parallelogram, but we've said it's a parallelogram. So what does that mean about these two lines? Well, they're parallel. We're actually trying to prove that the opposite sides are equal. But we've said it's a parallelogram, so those sides are parallel. Happy with that? Okay. So, would you agree with me then that angle DAC is equal to angle BCA? Why? So, it is. It's a Z angle thingy, but unfortunately we need to know the name of the Z angle thingy. And it's really weird because Z is at one end of the alphabet and A is at the other. As a hint. Alternate. Is that going to help? A Z angle, and then you got, like, it is the Z angle, but it's at one end and A is the name of it. It's an alternate. So they are alternate angles. Now, which were the lines that we were using? Which were the parallel lines? I've done them in red. Yeah. It's just important to know that because there's two sets of parallel lines. So you need to be sure that you're telling them which ones are the parallel lines that you're using for that particular case. Okay. So I'll just delete that line. There we go. Now, we also have a case where this angle in here, BAC, would be equal to that one. Would you agree? Yes, ma'am? Which is DCA. And the reason would be alternate angles, but I got different parallel lines this time. Yeah. DC, AB. Doesn't really matter which order you do them in. Okay. Okay, now we can make a big bold statement. I like big bold statements. Therefore, triangle ACD is congruent to triangle CAB. Why? I'm saying they're congruent. There's a statement I've missed in there. Which one is it? AC is, and I'm even going to write shared. Okay? So does that make sense? Okay, so now, what's our reason that I'm saying they're congruent? AAS. Therefore, what's the question asking us to tell? AB equals CD and AD equals BC. Now, why? Corresponding sides in congruent triangles. We all happy with that?